morning, or whatever time you're watching this. This is Electrolysis, chemistry final project, the final project for chemistry. Well, we're gonna be doing electrolysis. To make magnesium sulfate, you're going to need sulfate and the magnesium ion. So when you want to get these two, you obviously write them down. And to combine them, that this is 2 plus and this is 2 minus. So they cancel each other out. And you just add them together once. And that becomes MgSO4. This is an ionic bond because they aren't like physically together. So if you want to get these balanced, obviously you will have to do the equation, which is MgO, and this is solid, state symbol is solid, plus a sulfuric acid, aqueous, and then since it's making a salt, this would turn into MgSO4, magnesium sulfate, and water. This is an aqueous salt, and obviously water is liquid. And this is balanced. Now that this is balanced, and we have our magnesium sulfate, which is a salt, which is aqueous, we can now put it into 200 ml of water into our beaker for electrolysis. Now what we have here is the basic diagram of electrolysis. Now here we have the battery cell, which provides the electricity needed. Note that the shorter end of the battery cell on the diagram is the negative side, and the long end is the positive side. Just think of it as it has more, therefore it's positive. Here's the wire that comes down to the electrodes, the beaker, and the electrolytes, in which is just water, in which we'll be placing our magnesium sulfate. Now here we have the electrodes. They're named after which one they attract. So it might seem ironic that the positive one is called the anode, which is anion, which we know is negative, right? But it attracts, since it's positive, it attracts the negative one. And the negative one is called the cathodes. They are both known as electrodes, but they just have 2 different names to distinguish them. Here we have, you can also have alligator clips to keep the electrodes in place.
Baba Bowie.
If you're doing like a small scale one in like your home lab or like your school lab. So before we can actually put this through electrolysis, it's important to know in which the ions are discharged, as they also have a set way they start from the bottom down up to the top. So if you have hydroxide, and in my example we also have sulfate, the hydroxide will always go first. And for the cations, in my example, the Mg will go first. Lower than the magnesium, the hydrogen just turns into hydrogen gas, which lifts up out of the beaker. That's why the magnesium goes to the cathode first. Here's the cations and the anions. Hydroxide, right? And since oxidation always happens at the anode, you know what electrons are on in your equation. You do know what it turns into. It turns into water. So you have your H2O, but you have to balance it. So the only way to balance this properly is to add 4 in front of the OA, the hydroxide, and put 2 in front of the water. But then you realize you have two more oxygens on the left side, so you have to add O2 on this side. And obviously the state symbols for that, those are aqueous, liquid, gas, and electrons have no state symbol. As for the magnesium, what you have is Mg2+. You always have to use the ions because the aqueous ones obviously dissolve into the water. Therefore, they're separated from each other. since we know that reduction happens at the cathode, the electrons will be on the left side of the equation. So, and then that turns into tin magnesium element, which is solid. But now you have to well, the equation is almost balanced. You just have to add it to front of the electrons because it's 2 plus. So if you add 2 electrons back to its valence shell, then it just becomes regular and Mg2 plus is aqueous. Also, if you're wondering, the H ions turn into H2 because it's a diatomic element, and this is also a gas. As we know, this is a gas too. But since it's H2, you need to add this one. Since it needs electrons, it's 2 electrons as well. Just in case you're wondering. Thank you for watching my video. Bye.
I had to beat an old lady with a stick to get these.
Sulfate.